Hi everyone. Welcome in another session of AI/ML. So I'll just share the screen first. Then we will be starting off with different types of neural network. Okay. So let me just share my screen. Just a moment, guys. Yeah. Hopefully my screen is all visible to you people. So we will be discussing about the types of neural network. So for today's session, we'll start with CNN. So we will be starting with CNN. CNN is a type of neural network. So that is convoluted neural network. Okay. So let me just write it down for you. Mm. It's convoluted neural network. Okay. So basically what happens up here, so what is a CNN? So I just wanted to explain you what is CNN. So CNN is a smart brain of a computer, you can say, that is very good at looking at pictures. Okay. So it helps computers to understand or help the model basically to understand and answer the questions like is this a cat or a dog? Is this a person smiling or sad? Is this a car on the road or is it some other vehicle? Which model of car is this? These are the things that these are the ideas that we are getting from CNN. Okay. So while normal neural network are bad at images, because of that only we have taken into CNN, right? That is convoluted neural network. That does perform good with the neural networks well. So before that, I just need to just show you how it actually looks. Just a moment. So here only we will be having this. Mm, yeah. So this is the structure of a simple convoluted neural network. Okay. So before that, what we are discussing about why the normal neural network are bad at images. Okay. So you can imagine a photo. So imagine a photo. Okay. Now what happens? Now a photo or a photograph is made of thousands of tiny pixels, right? As you all know. So a normal neural network treat every pixel as separate and gets confused because of too many numbers, right? That has happened in case of neural network because photos are made up of pixels and not one, two pixel. It contains thousands and millions of pixels. Okay, thousands and millions of pixels. That's why. So based on that, the photograph that we are discussing about that is made up of pixels. That when we are just going ahead with a normal neural network, it actually treats each of the pixel of that very specific photograph as separate, and it get confused, and there are too many numbers into it, so is most likely to get confused over it. Okay. So CNN was invented to look at images like human actually do, and based on that it can segregate the image or segregate or take into action with the minute details that it can think of. Okay. So this comes under this. So now we need to understand how do we humans see the image. That idea we need to understand, and then the CNN is mimicking that idea of taking forward, right? So basically, how do humans see? So when you look at the image, you don't see each of the pixel, right? So we see the lines, the edges, the shape, the object. So CNN copies this exact idea. Okay. So how humans see it? Human doesn't consider entire image, entire all the pixels of the image. Human doesn't consider all the pixels of the image, right? So it doesn't consider all the pixels of the image. So it actually takes forward, like it actually takes the lines coming down to edges. Okay, just a moment. Coming down, we do see the edges. Coming down, we do see the shape. Next, we see the object, right? This is what we are doing. So entire same thing has been mimicked by CNN. So in a bigger picture, what we have, so CNN has all of these main layers to take forward it. So we'll discuss about that. So CNN layers, the very first one is the image. Coming down, we have the convolution layer. Next we have the activation, like the activation function that we generally take as ReLU, like the most common one. Next, coming down, we have the pulling layer. Then we have, like, we need to repeat this many times. This pulling, after this pulling layer, we need to repeat this many times. Then we just go down to flatten, right? Then we just move down to fully collected layer. And finally, we have the output where we are using softmax. Okay. So we will be now seeing each of them in detail. Like here, if you can see that there is the input, then we have the convolutional layer or convolution layer, whatever you call it. Then we have this max pooling layer and this dense layer. This dense layer is only called as the fully connected layer. Okay, so this is what it is. Now we will be seeing each of them, like what are the steps it takes in details. Okay, so now basically what happens, the very first step is image as number, that is the input. That is my input. Okay. Now what happens? My system or my computer doesn't see a image, right? My system don't like humans, a computer or a machine don't understand the image. It understand the pixel numbers. It understand the numbers specifically, right? It sees the numbers. So coming down, we have small image. I'll take a small image and based on that, we will be just taking with the numbers how it works. Okay, so image as number we are giving as input. So let's take a very small 3 cross 3 image. Okay, now basically what happens, let's just take the image likewise as 1, 0, 1. Next is 0, 1, 0. Like there should be a gap. Yes. And then we have 1, 0, 1, 0, 1. Like this, I have the entire data, right? Or if I need to just merge it together, yes. Okay, just a moment. Okay, it is not taking in the same place. Let me just try to just take it in the same one. Okay. It's what we have taken 1, 0, 1. Next, we have taken, okay, like that only we have to take 0, 1, 0, and then finally 1, 0, 1 again. Okay. So this is my matrix. This is my matrix. Okay. Yeah. So this is how my matrix is coming. So 1 means what? 1 means the white pixel and 0 means the black one, black pixel. Okay. Now this 1 is white and 0 is black. So this matrix is coming down in the input layer. Okay, it's come down in the input layer. So this we discussed about input layer. Next we have the convolution layer basically. What you call it's fine, convolutional or convolution, that is good to go for. So it's convolution layer. Okay, so what happens here? So this is the most important layer. So what does convolution mean? So like in a simple meaning, convolution means sliding a small box over the image and checking the pattern. This is what we are doing up. So let's just take it up like that. Inserting. Okay, let's insert a box. So we'll take it like this. We'll just divide it accordingly. So like this, let me divide. Okay. So now again, I need to just take it. Okay. So this is how a image is been prepared. So consider this one is an image, and the small boxes are the pixels, each of the pixels. Okay. Now basically, as convolution means like sliding a small box over the image and checking the pattern, right? So basically now let me just insert another box. So I'll take a box up here and I'll just go here. So the size of the box is small, so I'll go down here. I'll check the image, let check the pixels accordingly because underneath we have the pixels. Then we'll go here, then going here, then here, then here, then here, then here, then here. Like this, it is moving, right? The similar way things are taking in case of convoluted layer, convolutional layer. Okay, so this is the exact thing that things are taking in the convolutional layer. So convolutional means sliding a small box over the image and checking how the pattern goes. Okay, so suppose you imagine that you have a small window. You slide it over the image, right? You check it. Is there is line? Is there is edge? So what small windows is called is up here. In this case, this small window or this part is basically, so this is known as the filter or the kernel. Okay. So filter or the kernel, it actually goes one by one to the to each of the part and checks for the pixel, is there any lines present, is there any age present, or anything is present. Okay. Now, filter. What is this filter? So we'll just take a filter up. So filter. So filter or kernel. So in case of filter or kernel, we take a small filter. So what is this filter? We'll just get the filter like this. This is the filter. Okay. So this filter is good at finding the age. Okay. This filter is good for finding the age. I guess you have like if you have studied the subject called image processing, there you will get all of this detail things in details. Okay. So this is the filter. So it's good for finding the image. Now we'll go down to convolution step by step. Okay. So we'll go by convolution. So what happens? I have this image. So this is my image and this is my filter. So this is my filter up. Now what happens? It places the filter on the top left, on the top left portion. So top left, like this portion. So we have this, for this we have 1001, right? This is the data that I am getting. So if it is placing in top left, because it is 2 cross 2 matrix and it is 3 cross 3 matrix, so if I am placing a 2 cross 2 matrix over a 3 cross 3 matrix, I'll get the two numbers altogether, 1001. So what I have got, 1, 0, and I have got 0, 1. Right? This is what we have got. Now we need to just multiply the elements. So this is my image pixel and this is my filter. So I need to just multiply each one of them. So this is the image and this is the filter. Okay, so this is the filter. So what I am doing, item to item multiplication. One is multiplied with one because of the position. This one is coming with this. That's why we are getting this. Okay, control Z. Yeah. 1 with 1 plus I am doing 0 with 0 plus I am again doing 0 with 0 0 with 0. Just a moment. And then what we are doing, 1 with minus 1. Right? So this is my part that I am doing. Now we have to add it. So we will be getting 1 plus 0 plus 0 minus 1. So it is giving me the value as 0. Right? So this is how it is coming. So this output is coming as 0 when I am taking this from here to here like this. So this is how the data is taking. Now again, if I am taking for the right side, I want to repeat it the same way. Like from the left, it will move it down to right. So the same thing which will be happening. The filter will slide from left to right across the image. Okay. So the product, and we're getting the product of a new small image that we are taking. Okay. Now, what does convolution do? Convolution detects the line, the curves, the corners, and the texture. So this is how we are getting the values all together. So the lines and the stuff will getting extended. Okay. Now, this is the convolution layer. Now we have the activation function. Okay, so activation function, here we are taking ReLU activation function. So here what happens after convolution, we apply the ReLU. So if the value is smaller than if value is smaller than 0, we make it 0. Else, like if value is greater than 0, then we keep it. This is what a ReLU activation function does, right? So it removes useless information, keeps only the strong features. Okay. So before ReLU, if my datas are coming out as -2, comma 3, comma -1, comma 5, in that case, after ReLU, it becomes 0, comma 3, comma 0, comma 5. Okay, so this is after ReLU. This is after ReLU. Okay, now coming down to the pulling layer. Okay, so what happens in pulling layer? Pulling layer actually makes the image smaller. Okay, it makes the image smaller. So pulling layers helps to reduce the size, reduce the noise, and speed up the learning. Okay, so pulling layer actually reduce the size. Next, it reduce the noise and speed up the learning. Okay, so what is this max pulling? Max pulling is most common. Max pulling is most common, so it takes the maximum value from the smaller one and we are taking it all together. Okay, let's just take the example. So suppose we have 1, 3 and we have 2, 0 like this, and after max pulling into 2 cross 2, so we will be getting the max that is equal to 3, because among this 3 is the maximum value. So the image, if we are choosing this 3, so then the image becomes smaller and important features remain as it is. There is no issue, nothing that came out in the part of this part. Okay, so that is the major work of this max pulling. Okay. Now, why pulling is important? Now, if a cat moves a little left or right, CNN can still detect it. Pulling gives this position tolerance. Okay, so this is why we are using the pulling. Now, if we are taking this convolution, plus we are taking ReLU, plus we are taking pulling, that is actually repeated. Okay, so what exactly is happening up here? So basically, here we have got the ages that is coming with shapes, that is coming with parts. Then we have the object. So this is how the thing is moving, right? So like the first layer, we have got the ages. The middle layer, we have got the eyes and the ears. And the deep layer, we got the face. So that is how it is moving. Okay. Now we have the flattened layer. Okay. So this is from the image to list. So now the CNN stop looking like image. So it is coming down to the list format. Okay. So what is this flattened? It converts the 2D image into 1D list. What it does, it converts 2D image into 1D list. Okay. Now, for example, how we are taking it. So we are using the matrix. So we have the values like this 1, comma 2, 3, and 4. So this is the matrix. Now this is the 2D image. Now after flattened, it becomes as 1, comma 2, comma 3, comma 4. Okay. So this is coming out in the flattened layer. Okay. So now coming down in the fully connected layer. Okay. So now here, this is the normal neural network. This fully connected neural network is the normal neural network. So here, the neuron actually goes down with inputs, with weights, inputs into weights plus bias with the activation function, the one that we have taken initially for the simple neural network and all. So we this things will be taking in the same way. Okay. So how it will be taking? It will be taking input into weight plus bias, and this idea is going down to activation function. Okay, so it combines all the learned feature and decide what is the image it is. Okay, so for this, it is taking it like that. After this, we have the output layer. So what happens in case of output layer? So as you know, as in general case, we use the softmax. So there, what happens? We suppose we have got the values like 0.1, then 0.8, then suppose 0.1 again, like that. If I am getting the values, then that meaning is cat is 80%. Next is dog, that is coming out around 10%. And any other animal like rabbit, that is also 10%. Okay, so now the CNN layers training. So now how this training layers is going accordingly. Like these are the layers of till now whatever we have discussed, that are the layers of neural networks, right? But they need to be trained accordingly. They need to be trained accordingly. So now we will be discussing how the CNN learns, how the training happens in CNN. Okay. Okay, so now CNN uses forward propagation, loss calculation, and backward propagation the way that the normal neural network works. Okay, the same way. Okay, so CNN learns using forward propagation. Next, what it does, it goes for loss calculation. Next, it goes down for backward propagation, like back propagation. Okay, so this is how the things are moving. Now, as normal neuron works, but here we have the filters also that needs to learn automatically, right? So what it does, so at first, the filters are random. right? Here, not only the part, but here the filters need to be taken at automatically because CNN is based on the image only, like how better my image will take. And for my model to understand the image, what it is, it needs to we need to have the filter updated at the same way, right? My filters need to be updated. So for that, at first the filters are random, but after training, filters become age detectors, shape detector, object detector, like that. Okay, hope I have made it clear. So, like this way, these are the learning forms they are using, like the normal neurons. But here, basically, since we had to deal with the filters, so the filters initially we take the filters random. Initially, we take the filters as random. After training, the filters become age detectors, shape detector, object detector. Okay. So why CNN is so powerful in this case? It because it shares the weight. It needs the fewer parameters as for in case of others, and it learns the spatial pattern accordingly. Okay, so it works amazingly with the image you can think about. Okay, so that's why CNN is used in face recognition, in medical scans, in self-driven cars, in case of emotion detection. For all of this purpose, we use CNN, that is convoluted neural network. Okay, so it is basically CNN is basically the mixture of image recognition systems along with coming down with the neural network. We combines with that with the activation function, like the normal proceedings of image recognition system, that sorry, not image face detect not face recognition, image detection system that we already have. Along with that, we just combine the activation function and different neural network layers to to make it possible to come accordingly. Okay, so that is CNN. Now we need to have a proper idea about it. So CNN looks at image like humans. So we have the image, we have the filters, then we have the features. Then these features are coming down with the smaller features, then we are just flattening them and then thinking and deciding. This is how my entire CNN actually works. Let me again giving you the idea. CNN is basically our eyes, then the brain and the decision. That's why we are detecting the images, like detecting the part and then deciding what to do, right? So that's why for decide decision part, we are using the neural network, like the basic neural network part, and then coming down for the for in detail CNN, we just start with image, then we move it down with the filters as filters need to be taken accordingly. We move it down with filters, then we just go for features, and the features are going for smaller features are shrinking, right? Smaller features are shrinking using flatten, and then we go for a fully connected network, that is the normal neural network that is required for thinking and for decision purpose. Okay, so this is all about neural network, like CNN, like that is convoluted neural network. Okay, hope you have understood by now what is convoluted neural network. Okay, so now we just forgot to have a proper discussion about multiple perceptron, that is multi-layered perceptron. So before going down to RNN, that is recurrent neural network, that is another type of neural network, we have to had a discussion about multi-layered perceptron. Okay, so we'll have a discussion about that, and then we'll move out for the recurrent neural network. Okay, so it's multi-layer multi-layer perceptron. Okay, so a multi-layer perceptron is the computer brain made of many small decision makers that are working together at the same time. So each small decision maker is called this neurons, and multiple linear, like multi-layer perceptron is like where multiple of neurons are combined together to form a channelized neural network that that performs exceptionally well and just take help in making the decision accordingly. Help in making the decision accordingly. Okay, so hopefully you have understood what I am trying to say. So by the time we will be just going in details about it. Okay. So now what basically we are doing, like we have to I like need to have a proper idea. So let's just imagine a school. Okay. So now what happens? We have students. Students, so they are into the neurons. Then we have classrooms. That is also neurons. Next, we have teachers. So they are coming as a training basically. Basically, classrooms will be considered as layers only. So basically the neurons only, but layer specifications. Okay. So layer specifications. Next, we have exam, that is prediction. Okay. Now, hopefully you understood. So the information enters the school, then moves to classroom moves to classroom by the classroom and finally gets by gets and gives the answer. Okay. So this is the idea. So data is going down through neurons with the classroom, that is the layers, and goes down with the training purpose, and finally it gives the prediction. So is an example of an MLP. Okay. So now what does MLP mean? Like multi-layered perceptron means. Perceptron meaning by the time you already know. Now we have to just understand about the meaning of multi-layered. Why multi-layered? Multi means many. Multi means many. Layered means, as you know, the floors or the classroom. And coming down to the perceptron, it is a tiny decision-making unit. So MLP is many layer of tiny decision makers. Okay, MLP is many layers of tiny decision makers. So how it actually works, we have the input layer, then we have the hidden layers. So this is S, not a single hidden layer. There are multiple hidden layers. So that is why the name has came up as multiple. The name has came up as multi-layered perceptron. Okay, so there can be multiple layers altogether, and then we have the output layer. Okay, so this is the idea. So each layer has neuron, and each neuron does multiply, add, and decide. Okay, so this is the idea. Now coming down to input layer. Input layer is the starting point. Okay, so let's just take an example. Example is a predict if a student pass an exam. Okay, predict if a student passes an exam. Okay, so this is the thing. Now, what would be my input? There should be a specific input. So the input I am giving, that is hours studies and sleep hours. So maybe the hours studied is flow 4 and sleep hours, that is going at 7. Okay. Now, what is the input vector? Input vector is basically 4 comma 4 comma 7. Okay, this is the input vector. Now, what is a neuron in this case? So, neuron is a tiny calculator basically. So, as we have done all of the process like multiplying the input with weights, adding bias, applying activation function, everything it does. Okay, now here for this, the output is coming out as activation. Next, we have the input into weight plus bias. Okay, so this is what it is doing. Now, this simple neurons, as we have given, we have two X values. Like hours of study is 4 and hour of sleep is coming down as 7. Right? Now here what happens for this neuron, so one specific neuron, right? So we are taking the value of x equals to 4 and then we are taking the weight that is suppose 0.5 I am taking and the bias I am taking as 1, right? So what happens here? The value of z is coming out as 4 into 0.5 plus 1 that we are doing. So that is giving out the value as 4 into 0.5 that is 2. 2 plus 1 that is 3. Right? So 3 is my value. Now my output. Output is coming as we are taking the taking it like that. That is max 0, 3. So we will be getting the value as 3 here because 3 is positive. There is no negative value. So it's fine that we have to take it in this positive one only. So here we are applying the ReLU activation function. Okay. So weight and bias, all of you know about weight and bias. Weight is like how important my input are. Bigger weight that implies more important that input is or that value is. Okay. Bias is like the extra push, it helps neurons to activate even if the input is very small, right? So this is about this. Now coming down to the hidden layers. Okay. So we have then the hidden layers. So hidden layers combine the input, learn the pattern and make smart decisions. So why hidden? Because we don't see them directly. They are inside the like they are merged between the input and the output sections. Okay. So this is the idea. So now a small MLP numerically how we will be taking it that we will have an idea over. Okay. So it is an MLP that is multi-layer perceptron. So suppose we have x1 equals to 2 and we have the value of x2 that is coming down as suppose 3. Okay. Now we have to take into like from here we have to take it down to the hidden layers, right? Hidden layers contain two neurons. Okay. So we have to take it like that. So hidden layer for this two neurons, it will be coming out with the weights. So we'll just assign the weights. So weights is basically we will be taking, there are two values. So there should be four weights that needs to be taken. Two inputs, then there should be four weights. Okay, so let's take W1 as 0.4, W2 we are taking it as 0.6, W3 we are taking it as 0.5 and W4 we are taking it as 0.2. Okay, like this we are taking and there should be two biases. So B1 we are taking as 1 and B2 we are taking as 0.5. Okay. Now for the hidden neuron 1, because there are two hidden neurons. Hidden neurons, that is 1. Now basically what we are doing here for hidden neuron, so we are taking Z1 that is coming as 2 into 0.4 plus we are doing 3 into 0.6 plus 1, right? So I am getting the values here 0.8 plus 1.8 plus 1 that is 3.6. 3.6. Okay. Now, what this is the output for this. And now we have to apply the activation function. Activation function for Z1 that we are doing. So we are getting here 3.6 is positive number. So we'll get that only because we are using the ReLU activation function. Now coming down for the hidden layer 2, that is Z2, that will be coming out as 2 into 0.5 plus 3 is the input into 0.2, that is the value, that are the weights that we have taken, plus the B2 we have taken 0.5, so we will be adding that. So here my Z2 value will come up as 2.1 because 2.05 that is 1 plus 3 into 0.2 that is 0.6 plus 0.5 that is giving me the value as 2.1. Okay, now these are the values that is coming down to the output layer, right? So my values are 3.6 comma 2.1, right? These are the values that are going. Sorry guys. Now we have this value in the output layer, right? So output layer, I'll take the weight for output layer, that is W6 as 0.7 and W7, sorry, W6 and W7, right? No, sorry, W5 and W6. Really sorry, W5 and W6. We can take whatever be the name, but I just want to make it confirm because there are four layers, four weights we have already taken. This is fifth weight and this is sixth weight. So let's take it 0.3. Okay. Now, and the bias I am taking as 0.2. Okay. Now we have to do the calculation. So Z is equal to 3.6 into 0.7 plus I am doing 2.1 into I am doing 0.3 plus I am doing 0.2, right? So here I am getting the value of Z that is equal to 3.35. Okay, so now we are applying the sigmoid activation function. Sigmoid. Sigmoid activation function. Oh, here I am getting the value for this as 3.35. Okay. Now, basically here, what is the thing? It is 1 by 1 plus e to the power 3.35. Okay. So, around, I'll get the value around 0.9 something, like max to max. Okay. So, we'll get the value around 0.9. Okay. So, there is around, suppose, 9, maybe 996, like that. Like this, we will get the value. So that means there is 96% chance of the student getting passed. 96% chance to get passed. Okay. So this is the idea. So we have started from here and we have just gone here like that and we have got the values like this, and based on that we are just taking it this way, right? So we have just got the finding that there is 96% of the chance to get it passed. Okay. So now this activation function, as you all know, it is the decision making function. So activation function decide on or off or add, and also add the non-linearity, that is the card. So the most common ones we mainly used is ReLU, next is softmax, next is sigmoid. So without activation function, my MLP becomes dumb. Okay. So the MLP understands and learn in the same way, guessing the answer, checking the mistake, correcting the weight. That is the back propagation that we have already discussed. So we are not going in details about it. So MLP is many neurons at the same time. Neurons are like multiply plus add plus decide. That is giving the idea about neurons. Next is the layers, learns in step by step, and training is like learns from mistakes. So MLP is like thinking, and then deciding, because there are more number of hidden layers compared to single layer perceptron, right? In single layer perceptron, we only have a single layer of hidden layer, but in case of multiple, like multi-layer perceptron, we can have many, like 10 middle layers, middle or hidden layers as well. Okay, so that is the idea. Okay, now coming down to RNN, so we'll have a discussion about RNN today. So RNN, as you all know, so this is the recurrent neural network. So this is a neural network that actually remembers the past. Okay. So most neural networks looks at the input once and it forgets it, right? But what happens when we are using the memory? In that case, like RNN, basically what it does, it looks at the input, remember what it saw before, and it uses its memory to decide it better, right? So here basically with with it we are using the power of memory. Okay, so it remembers the past. It remembers the past. Okay, now coming down, we have the real life example of it. So suppose imagine that we have reading a sentence. We are reading a sentence. Like the sentence is, I am eating an apple. Okay, I am eating an apple. Okay, the sentence should be clear to you, I guess. So I am eating an apple. To understand the word apple, you must remember it, right? So I am eating an dash. So in this case, memory is needed, right? So RNN works exactly like that. RNN exactly works like that. So, what is the problem with the neural network, like the normal neural network? Normal neural network like MLP. Okay, so it treats every input separately, and it like I am just noting down the problems with normal normal neural network like MLP. Okay, so what happens here? We treat every input separately. Okay, we treat every input separately, then there is no memory, and of course, it cannot understand the sequence. Okay, it can't understand the sequence. Okay, so for example, suppose I want to predict the next word in the sentence, right? This it cannot do. It understanding the speech, it won't be able to understand the video, the understanding part it lacks. Okay, so this is the reason RNN is special, and we have just taken it accordingly, so that RNN can be taken it in that way that it read words one by one, remember the password, understand what is the order, learn the sequence, and based on that, we can take it further. Okay, now the basic structure of the RNN that we will be discussing. So we have the input, next we have, okay, let's just take it this way. So next, what we have, here we have RNN cell. So it is taking this way. We'll decrease it a bit like this. And here we have the output. And basically here it is packed by memory. It's packed by memory, right? Okay, so this is the idea. So this is the part. So the memory is called here. This memory is called the hidden state. Okay. So what is this memory? Memory is the hidden state. So you can think of hidden state as a notebook. It writes important things from the past, carries them to the future. But it is basically for remembering some of the important stuff. Okay. Now, how RNN works over time? Okay, how RNN works over time. Instead of one step, RNN works like time one, time two, time three, time four. Like this, it is working. The same RNN cell repeats again and again. Okay, so this is how it actually moves. Now, basically, let's take a simple story of predicting the next word. Okay, so suppose I have I have the sentence as I love ice cream. Okay, a very common understandable sentence. Okay, so now first it goes by time, right? It goes by time. So we'll have time. Next we have the word. Next we have the memory. Okay, so coming down here we have the time. So it's time one, like T1. So next I have the word, like the sentence as I love ice cream. So the my first word is I. So it is coming up as I, and the memory is it remembers I. Remembers I. Okay. Next we have time two. So we have the word as love. What it remembers I love. Okay. Next we have time three. Then we have time four. So time three is what? Time three is ice, and time four is cream, right? So basically, the same way it is going. So now it remembers I love ice, and it comes up like I love ice cream. Okay, this is coming up. I love ice cream. Okay, so this is the idea that this is how it actually takes in. Okay, so every simple RNN do some of the math that we have to take it further. So how the memory is getting updated? The memory is getting updated like new memory, that is F, that is function, that is current memory, current input plus old memory. Okay, so this is how it is getting updated. As you can see here, initially my first word, like initially my memory was blank for the RNN. So memory was blank, so I have fed in the data I. So it has remembered I. In the time two, when I have gone ahead, fed the new data as love, it remembered the previous data as I and attached the current input. So it has the current input plus the old memory. I plus love. It remembers it like that. The same way I love, it remembers. Next, my new input is ice. So my new updated memory is I love ice. So this it remembered already. My last update is about cream. So it has given the system as given like remember the sentence as I love ice cream. Okay. Okay, hope you understood the details. Now here about the part. about the H1 that we have to discuss. H1 here would be activation. Next, what we have WX into XX, okay? Plus, we are doing WH into H, like let's take it as some other, let's take it T, that would be better to understand. It would be T minus 1, okay, plus B, okay. So this is what we have to take it. So here XT, what is this XT? XT is the current input, like the current word that we have taken. HT1, that is my old memory. HT1 is the old memory. WH and WH are the importance of input. WX is the importance of the input, like the weight of the input, and WH, this is the importance of memory. Okay, we do give the weight to the memory as well. B is of course the bias, and HT, if we have to discuss about HT, because here we have used HT minus 1, that is the old memory, and HT is my new memory. Okay, so this is the idea about the RNN. Okay, now if I am taking the input, like if I am giving the input number, that is 2, and I have a old memory that is coming as 1. Okay, just for a reference, I have taken the idea. Now we have the weight. So we have suppose WX that we will be taking as 0.5. We have WH that we will be taking as 0.4, and bias value I'll be taking as 0.1. Okay. Now step by step we need to do the same thing. So we will be doing 2 into 0.5 plus 1 into 0.4. Right? This is what we are doing. Plus my bias is 0.1. So I get the value as 1.5. Right? So now this is the thing that we have taken. Now suppose I am applying tan H. So tan H keep small, like the values, whatever be the values, as very small, right? So my, like after applying activation function over this value of 1.5, let's suppose I have got the value as 0.9, 0.9. Okay. Now this memory goes to the next step. So this is my new memory. This comes down my new memory. Okay, my new memory is 0.9, right? So now this memory goes down to the next step. Okay, so in a way, how it is moving, we have input plus memory combination. Okay, so input plus memory, we are going for thinking, and then we are having the new memory. This is the entire idea. Okay. Now this output of RNN, how we are getting the output of RNN, right? So at each step, RNN can give the output or only give output at the last step. Okay. That depends on. Suppose I am taking the example of sentiment analysis. By understanding a sentence, I want to understand how the sentence is. Okay. Suppose I have the sentence as I do not like this movie. Yeah, this can be a sentence. So what is the output? Output is negative. Okay, because I am telling like I don't like the movie. So how RNN actually, how RNN learns? It learns through back propagation through time. Okay, RNN learns like a normal neural network, but what is the part? Error goes backward through time. Okay, error actually goes backward through time, so that's why it is learning through BPTT, that is back propagation through time. Because here is this concept of time over here, because we are going over time, because it is running more than once. Okay, so the problem is there, some of the problem is there with RNN. It's forgetting the old thing is is the problem of RNN. Okay, so what happens if the sentence is long? In that case, what happens? The early words are forgotten and the memory fades. Okay, the early words it forgets and the memory fades. Okay, so this is called vanishing gradient problem. This is called the vanishing gradient problem. Okay, now what is the solution to it? Solution is LSTM and GRU. Okay, so it have the memory gate, decide what to remember and decide what to forget, so that things become easier. Okay, things become easier. Okay, so RNN is basically used where it used in text, in case of speech. In text, it used in chatbot. In speech, we are using in voice assistance. In case of time series, we are using in stock prices. About music, we get it for song generation, for video, for action, like the what is the action recognition, for that we are using. And the types of RNN architecture, that is we are using one to one types of RNN. So it has one to one, that is coming down as image classification. Next we have one to many, that is image caption. Next we have many to one, that is as sentiment analysis. Next, we have many to many, that is translation. Okay, so this is the idea of a full RNN system. Okay, so RNN is neural network with memory, that is recurrent neural network. Memory is the hidden state. Memory, we call it as the hidden state. It works step by step and remembers the past. But there is a problem with that, that is called the vanishing gradient problem. That is basically it keeps on forgetting as the memory is increasing for long sentences. It the earlier word it keeps on forgetting, right? So and that is the problem. That is the name of this problem. We call it as vanishing gradient problem. Okay. So for that, the solution for this is LSTM, that is long short term memory, and we are using it basically for getting it through, like because we have a memory gate for in case of LSTM and GRU, so that what to remember and what not to remember, it can be taken accordingly, and what not to remember can be forgotten easily. Okay, so we'll just give an idea about LSTM. So it's like a three doors. So it's like door one, that is forget gate, input gate, and the output gate. There is three gates for it. So forget gate, what should I forget? input like what should I remember and output what should I tell in the next step. So this is the idea. So the memory has it has two memories. That is long memory, that is the cell state, and we have the short memory, that is the hidden state, that is already there in case of RNN. And for this memory, we have two division in case of LSTM, that is long memory and short memory. So it is good for long sentence, complex language, important long-term memory. We are able to use LSTM. Now about GRU, that is gated recurrent unit. So it is lighter backpack you can call about. So it has gates. It has a update gate and a reset gate. Update gate means remember or forget, and reset gate is like how much fast to use. Okay, so the memory is only one memory, but it is simpler than LSTM because in LSTM we have got two different memories, long memory and short memory. It is, and GRU is basically used for or good for faster training, for smaller data sets, simpler performance than LSTM. But major use we can do about for this solution of vanishing gradient problem is LSTM, that is long short term memory. Okay, so this is all about the types of neural network. Okay, so in the next session we will be going down in details about like how we can just take it further in case of how we can code it them, how we can train the model with all of them, how we can go for a neural network, a simple neural network, a multiple linear a multi-layer perceptron, a simple perceptron, a multi-layer perceptron, a ANN, a simple ANN, then CNN, then RNN. All of this we will be understanding in the next session through codes. Okay. So till then, we will be wrapping up our session today here. We will be connecting in the next session, and accordingly we will be moving down. Okay. So thank you everyone for connecting in today's session. We will be reconnecting in next session and completing this part of neural network. Okay. Thank you everyone. Bye for today.